Welcome to our second lecture on software requirements engineering. I'm Dr. Naveed. Before we start today's lecture, let's quickly recap what we covered in our first lecture. So the first lecture was just an introductory lecture. We started with introducing the course. In fact, we started with my introduction, then we introduced the course, we discussed the course contents, and I very clearly defined the objectives that we should have with this course. And we also talked about some of the learning outcomes that we should achieve, or the students should achieve, by the end of this course. Then we define what is a requirement, and just to quickly recap, a requirement is a service or it's a constraint on the system. Okay? In terms of a constraint, for example, we can say we can put an implementation constraint on the system. For example, we are building a website and we say the website should be built in ASP. So that's an implementation constraint. In terms of a service, we can say the website will give us information about something. So that's a service, and we discussed that what is a requirement. It's either a service or it's a constraint on the software. Then we discussed what are the different types of requirements, and we said that there are some general broad requirements, and then we derive some requirements from those general requirements. And mainly these are not main types, but these are, you can say, these are categories, or this is how the requirement process begins, that we have some general broad requirements, and then we use those broad requirements to derive more requirements. In general, the types of requirements, we have functional requirements and we have non-functional requirements. And by the name, it suggests that the functional requirements, they mainly describe the features or the functionality that a system would provide. And when we talk about non-functional requirements, then they include most of the things like reliability, for example, whether the system should be functional 24/7, or the system requirement is that it should be functional only 9 hours a day. And similarly, we can have some usability requirements, that the system should be designed in a way that it is very easy to use for all the end users. Then we talked about, very briefly, we defined what is a requirement engineering process, and we said that it involves all the sub-processes, so all the sub-processes and all the activities that we need to do in order to gather requirements, in order to manage requirements, and in order to specify requirements. They are all part of requirement engineering process. And we briefly talked about what are the different sub-processes which are involved in the requirement engineering process. So there is inception, in which we try to identify our key stakeholders. Then there is elicitation, where we try to gather, or where we try to ask stakeholders about the software requirements. And then we talked about there is an elaboration phase, where we try to elaborate and analyze those requirements that we have gathered from stakeholders. And then we specify requirements, then we negotiate those requirements, then we try to validate requirements, and finally there is the requirement management sub-process, where we try to develop a requirement management plan, and we also produce a requirement traceability matrix. So this was very briefly, we discussed requirement engineering process. Our following lectures would be on requirement engineering process. In fact, the course is designed in a way that we will discuss requirement engineering process first, and then we will look at all of those individual sub-processes in detail. Then I think there was something very important towards the end of the lecture which I wanted to mention, and we had a couple of slides towards the end of the lecture, and today we will elaborate more on that. And the topic was system engineering, where we try to identify different kinds of computer systems, and why we talked about that. Today, in today's lecture, we will be focusing on that what is the relationship between system engineering, and where do software requirements fall into that. And what is the difference between system and software engineering? So we are going to briefly discuss that today, and hopefully by the end of today's lecture we will be clear on that why we started talking about these things. So very quickly in today's lecture, as I said, we are going to talk about systems engineering, and where do software requirement engineering fall into system engineering. And then we will look at what a software requirements document looks like. And I have got a sample requirement document of one of the project which one of my students did, and I'm going to share it with you guys, just to give you a flavor that what a software, what an SRS may look like. It's not perfect, but I think it will give you an idea what are the different sections that we should have in a requirements document, and what are functional requirements, how we express non-functional requirements. So we are going to also look into that example. So let's start today's lecture, and again, I thought we should discuss on that why we talked about system engineering. Now, there is a difference between a system and a software. A software may be a combination of, at times, we have lots of different kinds of software. For example, if we are making a website, now that's simply a software, and we are going to deploy that website on some servers, and we are going to use it. And similarly, if we make an Android application, we'll run that Android application on our phone, and that's it. And if we make a desktop application which requires, for example, Windows operating system or Linux operating system, then it would run on that. Whereas there are other kind of computer software as well, which requires certain kind of hardware. So it's a mixture of hardware and software which makes the complete system. So when we talk about requirements engineering, in general requirements engineering, then requirements engineering also takes into account the requirements for the hardware, requirements for the other software. So basically it takes into account the requirements of the overall system. Okay, so that is very important, whereas this course only targets software requirements. So we need to discuss that even when we are making a system where a hardware is involved, where other servers is involved, where an embedded device is involved, or whether it is for a very complex chemical plant, for example, then there is very complex hardware involved. Okay, so there would be interaction between software and there would be interaction between hardware. So there would be some requirements which would be dealing with the hardware part. There would be some requirements which would specifically be dealing with the software part. So so we need to figure out that where do these software requirements they fit into this overall picture of system engineering. Okay, and this is where we started. This slide we also discussed in our last lecture, where we said that computer-based systems, they fall mainly into two kind of categories. So I guess now we can understand this much better, that there are two kinds of system out there. One are user-configured systems, okay, and the other are custom systems. User-configured systems are those systems which basically are configured according to a particular client's needs. So the systems are made with some general set of features in them, and according to a particular client, we customize it and send it to a client. Okay, and I gave you example of different ERP systems out there. For example, apart from SAP, Microsoft Oracle, there are certain open source ERP systems. For example, Open ERP is a very good example. Now there are lots of modules. It's an open source software which has lots of modules written into it, and you can customize those modules for different clients' needs and sell it to them. For example, it has a CRM module which is perfect. So you can sell it to a client who is looking for a customer relationship management software. You can sell it just the CRM module, customize it according to that particular client's need, and you can sell it to him. So these are user configured systems. The other kind of systems are the custom systems. Okay, a custom system is where a customer produces a set of requirements. So client would be telling you that this is what I need, and then according to that particular client's needs, you will produce something. Okay, so that is a project. Whereas user configured system are example of product. Okay, where you have a product, you configure it, and then you give it to a client. Whereas when we talk about custom systems, then they are built from scratch based on a client's requirements. Now there are three different classes of those custom systems. The first one is an information system. Okay, information system are those systems where the system needs to process some information which is stored in some database, and based on that it takes some decisions. The other kind of systems are embedded systems. Embedded systems where the software is used as a controller in some broader hardware system. Now there are very simple examples of embedded system. For example, a remote control, or there can be very complex embedded system, for example a chemical plant and things like that. Then we have command and control system, essentially a combination of information systems and embedded systems, where special purpose computer provide information which is collected and stored and used to make decisions. Now a very complex example of a command and control system is an air traffic control system. Now that's a very complex system which is a combination of embedded system and software system and information system. So it's command and control system, we can say it's a combination of the above two categories, information system and embedded system, and they are usually very complex system. For example, as I gave you the example of traffic control system. Okay, then another thing that we talked about is the emergent properties, and we said that emergent properties are those properties which we are not clear about at the beginning, but they emerge Okay, as we complete different individual modules of the system and we start merging them together, then these properties emerge. And what are the different kind of emergent properties that would emerge? For example, there can be reliability concerns, there would be maintainability problems, the performance might crash, or it may badly or worsely affect the performance. The usability may improve, or it can improve the security and safety. So for example, these are all the concerns that we need to take into account. So even when we talk about that this course only talks about software requirements engineering, we need to have this understanding that when we have a whole system, then how do we design a system? And in a system we have some general requirements which are system requirements. And when we will focus only on the software part of that big system, then we will talk about just the software requirements. But because this is a modular system which have different modules, the hardware part, the software part, and you deploy something on different servers, on different devices, and then when we merge them together, then things might not appear as we planned, and there can be some emergent properties of the system that come up. So we need to also take those into account when we are developing such systems. So this is one of the system engineering process, and as I said in our first lecture, that from the process literature, that people say that that every process, there is a process cannot be directly fit into a particular into a particular area as it is. So for example, if I am a company and I want to use a system engineering process, then I might have to tailor it according to my needs. Okay, so a process is only chosen depending on your context, and according to your context you need to tailor your process. Okay, so this is a very general system engineering process. It says that whenever you are engineering a system, then the first thing that you do is that you go for system requirements engineering. Okay, then you try to basically identify what are the requirements of the overall system. Okay, and the next phase is the architectural design. By architectural design we mean here that we try to identify what are the different modules. It is different from the software architecture, okay, which would basically follow software requirements engineering. But when we're talking about architectural design, then we try to identify different modules. And you can say that when we are designing the architecture of a system, we can also sort of have a clue that what is the architecture of the software as well. But after that we try to partition our requirements, and when we say partition our requirements, we try to identify that what requirements would be required for which portion of the system. For example, if we let's try to elaborate on that a bit. That for example, we say that when we talk about the architecture design, so we are saying that, let's say these are the different portion in my system. So we have a hardware portion, then we have a software module, and we say we have another software module. And so basically this tries to access information from this, and this tries to go and get some information from a database that I have here. So this is my DB, so it tries to access some information from my database, and this basically talks to the hardware portion and it tries to control something. So basically I would say that this is maybe the architecture design of my system. And when I'm talking about partitioning requirements, then basically I'm trying to identify that what requirements do I need for this part. So there would be set of requirements which would be used to build this embedded portion of the system, and there would be some requirements which would be used to build this software portion. And that's where the software requirement engineering bit fits into the whole big domain of system engineering. So you can see here that this is the software requirement engineering part, and from here onwards we say we'll go for subsystem development. So we are particularly trying to identify the software requirements. And as we discussed in our first lecture, that it is always trickier to identify, to define, and to specify a software requirements. Okay, and why? Because we discussed some of the reasons that people always believe that because it's a software, so things can easily change. So that's why there is a special focus on software requirements engineering. And by partitioning requirements, we say that these are the requirements for other parts of the system, and then we have some requirements which would be dealing with the software. And following the software requirement engineering process, we have subsystem development, system integration, and then system validation. So let's quickly see what we do in all these different phases of this system engineering process. So when we talk about systems, system requirements engineering, it essentially means the requirements for the system as a whole are established and written to be understandable to all stakeholders. So here we basically try to specify the requirements for the overall system. And when we say the architecture design, then simply the system is decomposed into subsystems. So a very crude and a very simple architecture diagram is what we tried to draw in our last slide, which basically has different subsystems. We had a hardware portion, then we have a couple of software modules. So these we decompose our overall system into different subsystems. And then we said requirement partitioning, where we try to allocate requirements to those different subsystems that we have identified in our architectural design. And in software requirement engineering, we put more detail into system requirements, and we try to derive software requirements from those system requirements. So as I said in the beginning, that there are different types of requirements. We have some broad requirements. So here you can say that the system requirement, these are broad requirements. And following the architecture design and requirement partitioning, then we try to derive the software requirements from those very broad system requirements. And then the subsystem development, the hardware and the software subsystems are designed and implemented in parallel. And when we talk about system integration, the hardware and the software subsystems are put together to make up the system. And this is where the emergent properties part comes in. When we have those individual subsystems, we test them and we try to ensure that they fully satisfy those individual requirements that we identified for those subsystems. But when we will try to emerge those different subsystems, that is the tricky portion, okay? Because it can cause lots of problems. It can cause maybe software to fail. It can cause maybe its performance to deteriorate. It can cause maybe safety concerns. So we need to ensure after our integration that the software is working as we want it to be. And then comes the system validation part, and that's the final portion of the final phase of the system engineering process, where we say the system is validated against its requirements. So we basically try to see that if the system is meeting all the requirements that were mentioned at the beginning. So this is generally the system engineering process, and we briefly talked about what are the different phases of the system engineering process, or what are the different activities in the system engineering process. Okay, then we have subsystem development. When we say subsystem development, then we talk about the hardware. We have different subsystems as we identified in the architecture design, the hardware part and the software part. We try to design them and implement them in parallel. And then comes the system integration bit, where we try to merge those different subsystems together. We try to integrate them. And that's where the emergent properties part comes in, because when we will try to merge different subsystems together, then the emergent properties would come in. Okay, because when we merge two systems together, then it may cause some safety concerns. It can cause performance to deteriorate. It can have some reliability problems. So we need to take into account all those things. And then the final activity, or the final sub-process of the system engineering process, is system validation, where we try to validate our system according to the requirements that we gather at the beginning. So this is as far as we are going to talk about system engineering and software requirements. But the idea was that you guys have an understanding that where do software requirements fall into the big process of system engineering. So now we come to our second part of today's lecture, which is our discussion on requirements document. And I thought it was necessary that I show you guys that how do we try to specify requirements, or what are the different sections of a requirement document. So let's quickly see what is a requirement document. It's a document. We basically define a requirement document as a formal document, as it is used to communicate those requirements with the customer, the engineers, and the managers. So it is a very important statement that when we say that a requirement analyst, he tries to specify requirements, then he doesn't only specify those requirements for himself. Okay, the purpose of specifying requirement is that this document would be formally used throughout the software development lifecycle. It would be used whenever you want to communicate something to the designers. It would be used when you're trying to communicate something to the testers. It will be used by the developers, and finally it will be used when we go for system validation. Okay, so it's a very important document. So what does a requirement document describe? It describes the services and the functions which the system should provide, and this is according to our definition of requirement, that it is either a service or a constraint on the system. So that then comes the second bit. It describes the constraints under which the system must operate, it describes the overall properties of the system, that is the constraints on the system's emergent properties and definition of other systems which the system must integrate with. So if there are other systems which you are not developing but they're out there and your system should work with them, so it also describes them, it also defines them. So this is a general definition of a requirement document. It also describes the information about the application domain of the system, for example, how to carry out particular types of computation. Okay. So it also describes that it constraints on the processes used to develop the system. So if you have certain constraints on how the system should be developed, that is also part of a requirement document. It also describes the hardware on which the system is to run. For example, if you are making an application for Android operating system, or it's an application for a smartphone, then you need to specify the hardware. So you need to be very clear for, and then even if it's a desktop application, then at times you see that, for example, in case of lots of games, it is specified that what are the minimum system requirements. So by minimum system requirements, it says that in order to run this particular game on your system should have, you know, a processor of, I don't know, a certain speed, it should have RAM, certain amount of RAM, it should have certain amount of hard drive, and these kind of things. In addition, the requirement document should always include an introductory chapter, which is important. And when we see at a sample SRS, as I said in the beginning of the lecture, you guys are going to see that what do we put in an introductory section. Then it also has overview of the system and the business needs supported by the system. This is also important, where we try to identify that the business objective, that when we build the system, how is it going to help the client. So what is the value in the system for the client? We also try to put that. And then there is a glossary section which explains main terminology that would be used throughout that particular document. Okay, now this is, we touched upon it in our previous slides, but this is also important to specify here that who are users of our requirements document. Systems customers, they are the users. Project managers, they are the users. System engineers, system test engineers, and system maintenance engineers, they are all users of requirements. So this is why so much importance is given to specifying requirements according to a particular template. Okay, and we are not going to discuss too much into it, but that's why these templates are important, and that's why I thought it's important that I show you guys a particular template of writing requirements. The reason why people say that if you are an organization building software, you are a software organization, then you should always try to put requirements in a particular template. Okay, the reason is that so that all your team members, they know where to find what kind of information. For example, if I am a system developer and I want to see what are the constraints on a particular system, and if my company follows a particular template, then I would know that where these constraints are written in a document. So I would go look at the document, go to a particular section, and if the template is with which I am very familiar, it would be very easy for me to figure out. Similarly, I want to see what are the non-functional requirements on the system. For example, I am a developer developing a certain module where I have to communicate with the database, and I want to know what are the limitations, or what is the performance of the database that is required of me. So I write my queries in an efficient manner. So basically, that's why these templates are important, that requirements are not just for requirement analyst, it's not just for project manager, it is not just for customer. So requirements should be written in a way that they are understandable to the client, they are understandable to the project managers, they are understandable to engineers, they are understandable to test engineers, they are understandable to the maintenance engineers. Now, having said that, so all parts of the requirements document may not concern all these users. Okay. So there might be some very technical information which the client is not concerned with. He just wants to know that what do you think he wants. Okay? But there should be some information for him so that he can understand that what you are trying to think. So the document should be written in a way that every one of these users, they get something out of it. So when we say that it is for system customers, we specify the requirements and read them. So what do the customers do? They read them to check that whether it meets their needs or not. And project managers use the requirement document to plan a bid for the system and to plan the system development process. So project managers, because they have to manage the whole development process, so they use the requirement document to actually do that. And system engineers, they use the requirements to understand the system being developed. Similarly, the test engineers, they use the system to develop the test cases and to test the system in order to validate the overall system. And finally, the maintenance engineers, they use the requirements to help understand the system. So basically, in journal, these are different categories of users of a requirements document, and our document should be prepared in a fashion that it is understandable by all these different kinds of users. Now, as I said that there are lots of templates of requirement document which you can find. IEEE also proposes a standard structure of a requirements document. Now, obviously this is one of the most used structure, but companies, what do software organizations do? That they do not actually straight away start using a particular template. What a good organization should do, it should basically adapt a template, and then they should change it according to their particular needs. Okay, for example, there is a particular client who wants some certain kind of information in the SRS document. Then as a good software developer or as a good requirement analyst, you should take into account that what kind of projects you guys do, and if there is something which needs to be added to this particular template, then you should try to do that, because as I said that according to your context you need to adjust. Okay, so and this is also true for a requirements template, that when we say that every company should have a template, so it does not mean that every company should follow this IEEE template, but this is a good starting point. It has some important things which if you put there in a SRS document, then it ensures that it is understandable by lots of the users that we mentioned in our previous slides. So normally a requirement document, it starts with an introduction section, and where we try to mention what is the purpose of this requirement document. We try to briefly describe the scope of the product. We mention all the definitions, acronyms, and any abbreviations that we are going to use throughout this particular document. We mention if we have any references, and then we try to give an overview that what would be followed in the rest of the document. So this is mainly the first main section of the requirements document. Then this section is followed by the journal description. Okay, in the journal description we try to give a product perspective. Okay, so we try to say that as a product, how this particular software would behave, and then we talk about particular product functions. We try to also mention what kind of users are going to use this product. Okay, and then we try to mention if there are any journal constraints that the client has put on it and that we think are necessary in order to develop it. We try to mention in this particular section of journal constraints. And then if there are any particular assumptions or any dependencies, for example, if the software requires certain kind of operating system to run on, then we need to mention that here. So any assumptions or any dependencies, they go into this section. So the second main section is the journal description. Now if you look at this, the hierarchy and the structure of this IEEE template, then it starts off with very journal information. Okay, so basically anybody who is not familiar with the product, if he goes through this introduction section, then it will build him up. So that's the idea, that you talk about that what is this document about, you briefly describe the scope, and you discuss some of the definitions, abbreviations, and when somebody goes through these three first subsections of the introduction, of the main introduction section, then he or she would be familiar that what kind of software we are talking about here. And then we talk about journal description. Again, these are not specific requirements, although we are talking about requirements document, but even till section 2 we are not talking about specific requirements. We are saying that again in section 2 we will generally build up. Okay, so we'll have some journal description about the product. And then comes the section 3, which is the main section where we try to specify requirements. Okay, now that's a very broad section, and the detail that is put into it, that can vary from software to software. It covers the functional requirements, non-functional requirements, and any interface requirements that we have on our system. And then there are different templates of writing a functional requirements and non-functional requirements. A functional requirement can be written just in natural language processing, so we just have some English, some language to actually describe. For example, the system should allow login facility, or a client or any user of the system needs to pass a correct username and a password to log into the system. So that can be a requirement. Or then there can be different ways of mentioning that particular requirement. We are going to see that what are the different ways of writing a particular requirement. And then if you have any additional information which you want to also attach to your requirements document, then you can also put that into it. For example, there is an appendices section, and the purpose is that, for example, if you made any use cases to for expressing the requirements, for eliciting requirements, you can do that. If you made a prototype, if you want to attach some information, you can put that in appendices. If there is any other system information that you want to put into appendices, you can do that. So this is generally the structure of a requirements document according to IEEE template. Now the IEEE standard is a generic standard which is intended to apply to a wide range of requirement document. As I said, that this is not for a particular client, this is not for a particular organization. Okay, so when we say that, so it means that in general not all the parts of the standard are required for all requirements document, and each organization should adapt, right? So this is very important, and that's why I'm mentioning it again and again, that you do not just adapt a template and start using it. You need to change it according to your needs. So let's say there is a company XYZ and they develop scientific instruments. Okay, so now how would they write or how would their requirement document look like? They can have a preface where this section may define the expected readership of the document and describe its version history, including a rationale for creating a new version and a summary of the changes made in each version. So you guys have read multiple books so far, so you can see that there's a preface section before the preceding the introductory chapter of the books, and it actually describes that what kind of readers this book's target. So you can also have a preface section. So for example, this company has a preface section, then they have an introduction. An introduction it should define the product in which the software is embedded, its expected usage, and present an overview of the functionality of the control software. Then they have the glossary, which is similar to the IEEE template. Then they have journal user requirements. Okay, this should define the system requirements from the perspective of the users of the system. These should be presented using a mixture of natural language and diagrams. In terms of diagrams, you can maybe use the use case diagrams, you can use any other diagram which you can build a usage model which actually describes that how the system would be used by the end user. Then according to this particular organization, they also put system architecture into the requirement document, and in this chapter, according to them, it should present a high-level overview of the anticipated system architecture, showing the distribution of the function across different system modules. So this is somewhat similar to the architecture design which we talked about in system engineering process, and we said we try to partition our requirements. So this is somewhat similar to that. And then there's a special section on hardware specification, because remember, this is a company which produces scientific instruments, and they always have some embedded part into it. So they have a special section on hardware specification. So this is an optional chapter specifying the hardware that a software is expected to control. It may be omitted if the standard platform is used. So for example, if we know that we are going to deploy this particular application on an Android phone, so we do not need to specify hardware. But if it's a particular type of a chip on which my software is going to work, then I need to mention the specification of that particular hardware, or what are the hardware requirements then that's become important. So that's why it said that it is optional. It can be omitted if it's a standard, but if it's something unique, then we need to specify that as well. And then this organization have a detailed section on software specification where they try to put all the functionality which is expected from the software. It may include details of specific algorithms which should be used for computation. If a prototyping approach is to be used for development on the standard instrument platform, this chapter may be omitted. So again, they have a special section on detailed software specification, and we have functional requirements into it. And they also say that if there are certain algorithms which are going to be used for certain kind of computation, then they also put that in there. And then they don't say that they put the non-functional requirements in the software specification part. They have a separate section on reliability and performance requirements. Now this is very important to note, that why they do have a separate section, because they are dealing with certain kind of hardware as well. So for them, reliability and performance is very, very important. So this chapter should describe the reliability and performance requirements which are expected from the system. These should be related to the statement of user requirements, and the information related to this, it can be found in chapter 4, where we talk about what are user requirements. We're going to discuss that in detail later on in this course. So the next main section in the for organization XYZ might have appendices, and as it is written here, that you're not going to put all the appendices in your requirement document. It depends on what do a client want, or what did you do in order to develop your understanding of specifications. So you will put only a certain appendix if it is necessary to gain understanding about the requirements of the product. So you can have an appendix on hardware interface specifications, you can have an appendix on software components which must be reused in the system implementation, you can have data structure descriptions, you can have data flow models, or if you made any object models, then you can also put that. But as I said, and then following that you can have the index section, which obviously is used if you want to go to a particular section of the document. So towards the end of it, let's quickly summarize that what we should gather from this our discussion on requirements document, that generally requirements, there is always a template for an organization, or all the good organizations, they have a generic template, but there cannot be one template for everybody. Okay, and we started our discussion with IEEE template, and we said that IEEE template is very generic. Okay, it has some very generic sections, but as a company or as a requirement analyst, you should try to customize that template according to your needs, according to your clients. Okay, and that's why we looked at this particular example of this XYZ company, where we said that this XYZ company have changed, they have changed the IEEE template according to their needs, and what was their context? Their context was different. They are not a standard software development company. They are a company which produces scientific instruments. Okay, and there is always hardware portion involved in it. So there was a separate section on hardware specifications. So this was one of the key differences. And then again, when they mentioned the software specifications, after that they had a separate section on reliability and performance requirements. So as a company or as an organization, depending on what kind of clients you have, depending on what is your portfolio, you basically develop your own template. So maybe a game development company would have a totally separate template. So as an organization, you should adapt a certain template, but you change it according to your needs. Okay, how do we write requirements? Generally, the requirements are written as paragraphs of natural language, and they can be supplemented with the help of diagrams and equations. Now, what are the problems with requirements? We discussed some of the problems with requirements, but let's quickly talk about them. So, generally, requirements would be problematic if we use very complex conditional clauses, which are very confusing. So we try to put conditions on every requirement, and it gets so jumbled up that we do not know that which requirements is dependent on what, whether requirement A is dependent on B or B is dependent on A, or so on and so forth. So we have very sloppy and inconsistent terminology, and the writer assumes readers have domain knowledge. So generally, as we have said, that requirements are written as text. Okay, and as I said in our first lecture, that one of the main reasons of ambiguity in software requirement is that requirements are expressed as natural language, and by definition there is ambiguity in natural language. Okay, so and to avoid that ambiguity, at times we try to mention equations, we try to put diagrams, so that our users or our readers get the same meaning out of what we have written. But if we try to put too many complex conditional clauses, then it can cause problems. Similarly, if we have inconsistent terminology, then it can cause problems. And also we should avoid using very particular domain jargon in the requirement document. We should try to express it in a fashion which is understandable for all the users. And remember here, the users of the system. In today's lecture, we talked about who are the users of the system. So who are the users of the systems? The user of the systems are your client is one user of the system. So client is one user of the system. Then you have your project manager is another user. Your developer is an other user. The tester, they are also the user. So we have different categories of the users. And the developer, he might not be a domain expert. Okay, so when we are expressing requirement, they should be expressed in a language which is understandable for the developer, because he is the one who has to develop the system. So this is very important to consideration that we need to take into account. Next up, we have what are the writing essentials. So requirements are read more often than they are written. So this is a very important statement, that we are going to write our requirement once. We might need to change it again and again, as we say that there are often changes in requirements, but but they would be read many more times than they are normally written. So for example, analyst would read it, customer would read it, they would read it again to resolve the conflicts in it, then designer would read it, developer would read it, tester would. So there are so many people who are going to read it again and again. So a lot of effort should be invested in it so that requirements are written in an understandable fashion. And again, we should not assume that all the readers of the requirements have the same background and use the same terminology as you as a requirement analyst or as a domain expert. So you should try to consider all the users of the systems and then allow time for review, revision and redrafting of the requirement document. This is something which is very important. If we produce a SRS document and we don't give enough time in the overall software development lifecycle to review the document and redraft the document according to the changes that is suggested by different users, then we are actually causing problems for ourselves in future, because it means that if we are not reviewing the document, then there might be or there would be some inconsistent, there would be some unclear, or there would be some requirements which are not clear for some users of the system. So we should give ourselves some time to review the document and redraft the document according to the changes which are suggested by different users of the SRS document. So what are the writing guidelines for software requirements? So let's quickly summarize on that. So we should define standard templates for describing requirements. Use language simply, consistently and concisely. Use diagrams appropriately. Supplement natural language with other description of requirements, and specify requirements quantitatively. Now, this is very important, and if we keep those guidelines in our mind whenever we are trying to specify the requirements for our system, then it will, I'm sure it's going to help you in producing a better document. So first thing is that define a standard template according to your context, and then the language written, it should be simple, it should be consistent, it should be concise. Why it should be simple? Because we have so many users, and all the users, we need to think about the background of different users when we are writing requirements. Similarly, the next step which is very important is that use diagrams appropriately. Now, as a requirement analyst or as an analyst, when you are producing this requirement specification document, then you should not try to put every diagram that you know about in an SRS document. You should only use a diagram if it is required. For example, if a DFD is required, put a data flow diagram there. If an object diagram is required, put an object diagram there. If a use case is required, put a use case there. So only produce a diagram if it is appropriate for the particular product or for understanding of the specifications that you have written in the document. Similarly, you should try to supplement the natural language or the requirements that you have expressed in natural language with other descriptions. And again, as we said, diagrams can be one way of doing that. And then try to specify requirements quantitatively. I know it is not possible all the time, but it is very important. For example, in case of non-functional requirements, when we are trying to say what is the performance expected of my system, okay, then I should be very clear, I should quantify it. An expression like the performance of the system should be good is not sufficient. You should try to say that all the queries should be, the minimum time, execution time of a query should always be less than 5 seconds or less than 10 seconds. So there should be quantitative statements whenever you write requirements. So generally, keep these guidelines in your mind whenever you're trying to express software requirements. Okay, and as I promised towards the in the beginning of the lecture, that we are going to discuss an example. So this was one of the projects that one of our students did for our university. Was that that students they're standing at bus stops and then they're waiting for buses, and there might be lots of problems. For example, the bus is stuck in the traffic and it's late than the normal time. So we wanted an application where a student can see where his or her bus is on a particular route. So we made an Android application for it. So let's quickly see, go through the problem statement, and then we'll look at the requirement document for that particular project. So the students using buses as means to get to the campus face problems when buses are late, especially when they have to wait for buses under scorching sun or heavy rain. This application intends to facilitate students by providing means to track buses in real time, which will not only allow students to view location of their buses and get to stop on time, it will also facilitate the transport office to keep track of all the active buses. So this is a very good problem statement, because it clearly mentions that why we are developing something, and who are the intended users of the system, and what these users should expect from the system, or how are these users are going to use this particular product. So in the meantime, I'm showing you the requirement specification or the requirements document. I also want you guys to think about that who are the users of this particular requirements document, and who will be the users of this particular system in general. So think about these things, and we're going to discuss that after I show you this particular requirements document. So this is the template that was used for writing or specifying requirements for this particular project. So it says software requirement specification, and it gives the project name, and then there is some version history that this is a reproduced version, and there were some changes in it. And then we have this table of content. So if you look at the main sections, then it follows more or less the IEEE template, because it has the introduction section, then it has an overall description, then we talk about system requirements or specific requirements. Then there is a section on what figures are produced to express then there is a section on list of figures, which mentions that which kind of diagrams are used to express the requirements or to gain better understanding of the specifications of the system. Then you can also have this this section on revision history, which mentions that how many times this document was changed, and who changed the document, and why it was changed, and what is the current version of the product. So this section is normally very important, because whoever is the reader of the document, he should ensure, and in order that he always is going through the latest document, this section should always be updated. If a document is revised 3 times, then the version number should be written here, that which version was revised, and your document should have the newer version number. So this is very important, that this version number needs to be updated very diligently. Okay, so now here it is. So in the introduction section, you can see that it just mentions that what this document is. It's a general introduction. It says that student using buses as mean to get to the campus face problems, and so it is more or less the problem statement that I showed you in the beginning, that what this product is about. So the next subsection is the purpose, and it's the purpose of the requirements document. And it says the purpose of this document is to specify the functional and non-functional requirements of the bus locator project. It sets by providing an overall description of the project through product features, functions, and by specifying constraints and assumptions of the project. And then we talk about the scope of this particular project. So when we say, and again, this is not the scope statement. In terms of project management, you should keep this thing in mind, that a complete scope statement is only generated once we have the complete set of requirements, and scope statement is followed by. So this is very brief scope of this bus locator project. This is not the complete scope statement in terms of project management. So let's say, what is the scope? It says that bus tracking system will provide schedule, route planning, and vehicle tracking. For students, it will provide estimated arrival time for a given route or stop based on real-time GPS information. This project will have 2 main modules, the client student module and the server or the transport office module. In fact, it had 3 modules, and there is a mistake in it, which had the driver module, because the drivers on the buses, they also had an application on their Android phones which used to send the current location of the bus to the server, and the server used to communicate that to the client. So there's a small problem in it, so maybe there is a revision that is required. So the next section was definitions, acronyms, and abbreviations. So there is what is GPS and what is an SDK, and then the references. So the 2 references which were used to produce this document was some Android documentation which was taken from developer.android.com, and then the IEEE document standard which is used, the reference is given to that. And then there is an overview section which actually mentions that what is to be followed in the rest of the document. So in the overall description chapter, the first section we have is on product perspective, and it just tells us more about this bus tracking system product. So it says the bus tracking system is a multi-purpose solution for transport office and students. Individual modules will offer following features. It has an end-user application, and within an end-user application, it briefly, this document tells what would be in the and user application. So student will be able to configure application, student will be able to update their status, application running on the driver phones will update GPS location of buses on the server. And then on the server side, the transport officer would be able to see live status of the buses. And buses route history would be maintained, that whether on a certain day a bus followed a route or not, and number of students on board on a particular route can also be calculated, will be updated on the server as well. And the next section is of product functions. So again, we are talking about some of the functions of the product. So what are the main functions? That location of buses on the server side and the client side, this is one of the main functions. Then user registration, this is another main function. Then configuration at the client side, this is another main function. Maintaining history of the routes, this is another function of the product. And the student will be able to update their status on social websites such as Facebook and on the server side as well. And the route history would be maintained, which is kind of optional. So this section builds on the information that we already give. So here we talked about product perspective, and then we are talking about what are the particular function that this would provide. And then we're talking about the user characteristics. So this is again a very important subsection where we are trying to mention that who are the users of the system. Because why this is important? Because when I mention the users of the system, and when I'm trying to design the interface of the system, then depending on the background of my end users, I will be able to design my product more appropriately. So it would help me in mentioning the interface requirements of my project. So there are mainly three users. We have drivers, we have users at the server side, maybe the transport officer, and the students. And again, we are mentioning that how these users will be operating this particular product. So drivers will not be interacting with the application as such. Their GPS devices will be used to update the location of the buses on the server. So a driver needs to enter his information just once. So this is a very important information that we get from this document. User at the server side should be able to use websites to track status of buses and to view the history of the routes. So this is another important information, that the server side users, they only will use the website or the web portion of the system. So they will basically only look at the current location of all the routes on a website on the server side, whereas students would be able to view location of their bus through their smartphones. They would also have to configure their application to signal alerts. So this gives so you can see that this is actually building up. So we talked about some general product, we talked about the product perspective, then we talked about some of the main functions, and then when we talked about the user characteristic, we are also mentioning that in what ways different users are going to use this particular product, which gives us more information. And then we talk about some of the constraints. The first constraint is that the client-side application will be developed as a native Android application. Specifically, it will be developed for Android 2.3. It will be operable only on devices running Android operating system. So basically, it's a smartphone application, and because it's a native Android application, so only the students with smartphones which have Android OS would be able to use this particular application. So that's a constraint. And then one of the assumptions and dependencies is that first assumption is that the student should have these Android phones in order to use this particular application. And because we are talking about tracking buses in real time, and when we say that the GPS location would be sent from driver to the server and then from the server to the student, so there would be some amount of lag. So that's a dependency problem that we have. So we need to cater this into account, that how we basically adjust that delay when we show that location of the bus on the student's phone. So this is mainly the second chapter, where we talked about overall, where we tried to build on our where we tried to give some more information to the reader about what the system is about. And then we have specific requirement sections, and the main subsection, one of the main subsections is the functional requirements. And as I said, that there are different ways in which you can express a functional requirement. So the first functional requirement which is written here is the get bus location. And you can see that this in this particular template, a tabular form is used to express requirements. And in this tabular form, there are multiple sections. So we have identifier of a requirement, we have title, we describing the requirement, we are putting the rationale for that requirement, any restrictions and the risk that will occur because of this requirement, any dependencies of this requirement, and priority of this requirement. So as I said in the beginning, that only if we just describe that what the requirement is, that's enough. That's not enough, but that is also a requirement. But by putting this in tabular form and trying to give some more information, I am actually making it more understandable for the users of this particular document. Okay, and this will increase my understanding of the system as well. So when we put, and that's why I said that a requirement is written only once, but it is read many times. So if you put some effort in writing that requirement, then it becomes very understandable, it becomes very easy to read later on for all the users of this particular document. So let's talk about all these different portions of one requirement in this table. For example, why do we need an identifier? So identifier is very important. Why it is important? In the later portion of this course, when we talk about the requirement management plan and one of the or the requirement management process, one of the things that we produce as a result of requirement management process is the requirement traceability matrix, which is used to trace the progress of a particular requirement throughout the system. And identifier is very important. For example, for me to figure out, for example, what is the identifier of this first requirement? It is FR-1. So for me, it will be very easy to write FR1 instead of this whole text in the traceability matrix. So if I want to see that what test cases do I need to write for FR1, so it will be very easy for me to figure out. Whereas if I write this whole text, then it will become very confusing. So normally it's a very good idea to give a unique identifier to all the requirements that you write. And then a title is a very brief description. So title is same, which is written here, that get bus location is the title of this requirement, and what this requirement is about, this is description of get bus location. It says that drivers of the different routes shall be provided phones through which GPS locations shall be transmitted via GPRS network. Current GPS coordinates shall be updated on the server every 30 seconds. So again, you can see that this statement is quantitative. We have not just said that the current GPS location is updated, but it is also mentioned that how frequently it should be updated. So every 30 seconds the new GPS location should be sent to the server. So this is a better statement. And then what is the rationale? Why do we need this feature why do we need to have this service in the bus locator project or in the bus locator software? The rationale is that this requirement is central to the project because the client-side application, the application which would be running on the student smartphones, it depends on the current location of a bus. So a server shall get location of each bus. So this is a very important requirement, and that's why you can see the priority of this requirement is high. So that's why it's high. And it has no dependencies as such. The only dependency it has, it is mentioned in the requirement that the drivers should be provided some phones, but it does not have any dependency with any other functional requirement. So similarly, all the other requirements of this product are expressed. For example, main location of all buses and view bus location on the server side. And so this is the general flow of the document. And these are all the functional requirements of the document. What we will try to do is that we will try to continue our discussion of this particular document in the next lecture, and we will just wind up what we have done in today's lecture, and when we will come back in the next lecture, we will continue with this document. We'll finish this first and then we'll move to the next lecture. When we started our discussion on this particular example requirements document, I asked you guys to imagine who are the users of requirement document of the bus locator project. So there are four different kinds of users. We have end users or the client, and when we talk about the end users, we have bus drivers, we have students, and we have the transport office. And in transport office, we can have multiple transport officers who are going to use this particular requirements document. We have project managers, we have development team, and we have the testers of the system. So these are users of the bus locator project. As I said earlier as well, that we are not been able to finish this example requirements document. We will continue that in our next lecture. But let's quickly summarize that what we have covered in today's lecture. So we started our discussion today with systems engineering and what is the relationship between system engineering and software requirements. I showed you guys a systems engineering process and where software requirement engineering fits into the overall picture. And then we talked about that what is a requirements document, and we discussed some of the guidelines that how should the requirements should be produced. And we said that we need to adapt a template. And when we adapt a template, we do not use it straight away. We customize it according to our needs. And requirements should be written concisely, clearly, and they should not be too much technical jargon or domain jargon in a requirement document. And then the requirement document should include a system overview, glossary, and statement of the functional requirements and operational constraints. So that's it from today's lecture. In the next lecture, we will start with our example that we were discussing today, and we'll move to the other topics later on. Assalamu alaikum.